everyone. I'm going to do a quick review of last week, and then Duncan will lead the session today. Okay. So if folks remember, last week was a pretty heavy week. We tried to combine a lot of our learning from previous weeks together to sort of walk through a typical data analysis pipeline, or what we called a pipeline, basically step by step. We went through the same HIV patients data set that you've been working with. We talked about how to start from scratch in terms of opening up a coding document, writing an informative header to say who is coding, when are they coding, how you typically load your packages, which you learned about in the first couple of sessions, how to what we called anchoring the script, how to use the here package to make sure you're using relative file paths for your script and your data. Then we imported the HIV data set using some of the methods that Duncan had taught us from before. Then we took a data snapshot. So if you remember, we used this package or this function called a package called skimr to take a quick look at our data. Basically, the idea behind taking a data snapshot is to take a look to see if there's anything unexpected. And the data set that we were working with I purposely made some mistakes in the data set. So we had one patient who was over 900 years old, which makes no sense. We also had somebody whose gender was coded in terms of words instead of numbers. So that made the data set confusing. So by taking a data snapshot, we were able to identify things to fix, which led to the sixth step here, which is data cleaning, which, as we found out, ends up being 80% of our work. So most of our work ended up being fixing those errors, but also standardizing any variables, creating new variables, and then finally having a data set that we could use for tables and for visualization. We then went on to answer a couple of questions using our data set. So we used tidyverse conventions. So we used that pipe operator and tried to, filter our data set by those who were HIV positive. Then we used functions such as group by and summarize to print out values for medians, interquartile ranges, basically answering these questions using a step-by-step process. And for anyone who missed it, the recording is available, but also we have uploaded the data set we used and the code that we ended up with. We uploaded all of that to Afredac. So please do, I encourage you to kind of comb through it, make some changes if you wish. And if you want to challenge yourself, you can also open up the Excel sheet, the data set, introduce your own errors into it, send that data set to a friend and see if they can kind of clean it up. And identify where you made mistakes in the data set on purpose. And then finally, we talked a little bit about data visualization. We introduced this package called ggplot and the function ggplot that basically is the workhorse function for data visualization in R. GG just stands for grammar of graphics. This plot works a lot like how tidyverse works in coding. So it works off of layers. So you're adding to the plot layer by layer, starting off with a blank canvas, then telling the plot what to put on the x-axis versus the y-axis. And then adding things like points and lines and bars and customizing the colors. We didn't go too much in depth on purpose because that's what Duncan is going to do today. He's kind of the master of all things data visualization. So you're in really good hands, but we did introduce it last time. So hopefully some of the terminology is familiar to you if you were here, if you watched the recording. So I'll pause there and before we start, just to see if there's any questions from last time or any clarifications that need to be made before Duncan starts. See any messages? Maybe it's all good. If there are any questions as Duncan is presenting, though please ask and we can resolve them as we go along. There we go. Over to you.
Yeah, okay. Thank you so much, Ashna, for that review of last week's content. And I think, as you have said, the biggest part of the work, or the biggest chunk of the work, has already been done, and that was data cleaning and actually formatting that data in a way that you can derive insights from it. Okay. So today we'll be looking at an introduction to data visualization, and this is just a culmination of what we have been doing all along. That is from the data importation, data curation, and now we want to visualize the data that we have already cleaned. Okay. So now, why is it important to actually do data visualization? We say that data visualization basically broadens the context and simplifies the information which is in that data, so that it can be easier to understand and also communicate. Okay, and through this visualization, is also possible to actually highlight patterns, whether there are any trends. You can also be able to see whether there were any outliers in that data set. And also, through data visualization, it actually gives you a way to actually explore that data even more. Okay. Then I know for some people, if you have been writing reports and reports, or either doing presentations, you will find that when you actually describe numbers, um, it's a bit cumbersome than a person who will use visualizations, because visualizations basically enhances effectiveness in actually passing information that is derived from that data. Okay, and that's why we are thinking that data visualization will be a critical component in communicating what the data is all about. Okay. Now, what are the principles of effective data visualization? So we are saying that for effective data visualization, there has to be clarity. Okay, in that the message is not lost in how that visualization is being done. So it has to be clear, in that the key information is actually captured in that visualization. Okay. The other thing is that for you to have effective data visualization, there has to be a component of accuracy. Accuracy in that you don't end up misinterpreting trends. Okay. And the data is visualized accurately. Okay. And the other principle is that we also need consistency, in that don't mix so many visual styles that that the the person who is consuming this visualization has a task of determining why you using so many patterns. So it's always good and recommended that you are consistent. You are consistent, so that if it's a certain visual style that you're using, or a certain design of the elements, ensure that this is consistent across different parts of that visualization. Okay. Then the other is that they have relevance. That you prioritize the information that is needed for decision making. Don't just do a visualization of all the components or all the data. You must have an objective of what you want to communicate, and through that, you can only pick, or you can only prioritize the information, the important information, or the crucial information that is needed for that particular decision making. So that is on the principle. So there has to be clarity, there has to be accuracy, there has to be consistency, and there has to be relevance. Now, when it comes to R, in the base R, there is there's a function which is called qplot, and it's a short form for quick plot. This one comes in base R, and it can also be used for visualization. But in the future, and I think in the current versions of R, they are removing it. It's deprecated because they want to encourage people to shift towards the ggplot that Ashna had introduced last time. Okay, so this is a package that we are going to use, which is called the ggplot, and the way we will just load it is just say the way we load the packages. We just say library. So you can in your um, in your R environment, you can just open a new script. Maybe you can save it as a visualization because that's where we are going now to use to do all the visualization. And please ensure that all the steps that Ashna did last time are included in that script because up to this point, we are assuming that the data has been cleaned. So that the data has been cleaned and it has been manipulated. So for us, this step, we just want to visualize that cleaned data set. Okay. So just a quick recap is that a qplot has been deprecated. So let us load our ggplot2. That's how it will be loaded. There is ggplot2. And for a person who has already loaded the tidyverse package, tidyverse also includes a ggplot2. So there may be no need for you to again load ggplot2. So tidyverse includes that ggplot2. And so I think it will be important, first of all, understand the building blocks of a visualization using ggplot. Okay, so these blocks, and as Ashna said, that a ggplot is a layered visualization. And what do these layers include? So one of the components, or what we'll be calling the building blocks of ggplot, the first one is the data. You must have a reference to the data set that is going to be plotted, to the data set whose elements are going to be plotted. That is and for our case now, we have the cleaned HIV data.xlsx. Okay. So after loading our ggplot2, we'll also now also load Rio so that we can import our data now into that R environment. The other component which we are looking to look at is what is called the aesthetics. It's also another building block of ggplot, whereby this involves the aesthetics and attributes such as the what goes to the x-axis, what goes to the y-axis, what will be the colors, how do you feel some of those shapes and etc. So data, aesthetics, then the other building blocks is what we're calling the geometrics. How do you want to visualize this? Do you want it to be a histogram? Do you want it to be a line plot? Do you want it to be a scatter plot? Do you want it to be a box plot and etc? Okay. So all those are just options that we can always choose when you're using ggplot to enable you to display that given component of that data. Then towards the end, once we actually looked at some of these components, we'll also look at facets. Facets, it just enables you to display subsets of that data using columns and rows. And you'll see this is actually a very good function if you have data sets that have things like gender, that has things like different regions. So you can use facets or even different year periods and you would like to maybe to display that data set, maybe for the columns you want to display the region, and for the rows you want to display the year. So it's just a very beautiful function, or a very beautiful building block that is in ggplot. The other thing will also, another building block is also what we call the statistics. You may need to actually, if it's something that, if it's a data point that you have used, maybe a point or a scatter plot, you may need to do some kind of a smoothing or maybe a fitting to that data. That comes into what we call statistics, okay? Things like binning, that is for histogram of bar charts, and etc. Then we'll also have coordinates. It's also sometimes it becomes necessary for you to have a user-defined limits of the axis. Maybe whatever is being plotted, it's plotting uh, in regions where you even don't need to actually visualize that data. So you can actually user-defined limits for that data, and this way you can use a component which is called coordinates. Okay. Then we have themes. So these themes, it has nothing. It has no connection to the data. But what themes improve, they just improve the outlook of that given visualization. Okay. So those are the building blocks. I was just trying to expand on what Ashna uh, described last time during the session. So data, aesthetics, geometrics, facets, statistics, coordinates, and themes. Those are the building blocks of a ggplot. So there are different types of visualizations we look at. We look at scatter plots. Okay, this just gives you a relationship between two different continuous variables, and it will just plot for you on a Cartesian plane. That is just an x and y plane. And for this one, you can decide to use different colors of those points, of those point scatter plots. You can use different shapes, sizes, and etc. We can also have bar plots to compare the categorical variables. And for this one, maybe now the bar plots will come in handy when we want to compare the different numbers of the people who are HIV positive for a given age group. That the way Ashina had actually grouped the people in that data set. Then we can have line plots. Uh, Line plot, this is, we can just use line plot to actually show trends or patterns over time. Then we can also have box plots. Box plot, this one, you can use this one if you're interested in looking at the quartiles, or if you want to identify any outliers in that data, or even if you want to identify central tendencies, things like mean, median, mode, variation, skewness, and etc. Then for the case where we want to look at the frequency distribution of a continuous variable, then in this case now we can use histograms. So these are just part of the types of visualizations you can use in R, but the way these these different types of visualizations are called, though we'll look at it shortly, is that there is this prefix which is called geom. Then there's an underscore. So whatever follows the underscore now will actually describe the different types of visualizations. Okay, we'll just see that shortly. And what actually happens is that ggplot has there has about 40 geoms, and these geoms is just the geometry. What do you want? Do you want a box plot? Do you want a scatter plot? Do you want a line graph? Do you want a time series plot? So there are over 40. So you can see there are so many. And if you'd like to see the different types of the geoms, you can look at there's this link which is here. I think I can post it in the chat just shortly. Okay, I'll just post it shortly. So you can follow that link, and you can actually look at all the over 40 there are over 40 geoms that are used in ggplot2 in that package. So it's a very powerful package. So like the common ones that we can use, you can see there's this geom which is the prefix and the underscore. Then after that, you actually describe what type of visualization do you want. So you can see histogram. If I want a bar chart, I can use the geom underscore bar. So don't worry about this parentheses, because inside this parentheses of the geom, like geom histogram, that is where now we can actually load our options. How do you want this visualization to be? Okay. So the others, like the box plot, we can have geom underscore box plot. If it's you want to look at points, the scatter point, the scatter plots, you can use the geom point. If it's a line graph, you can use the geom line or the geom path. Trend lines, you can use the geom smooth. So these are options of choosing different types of visualization. Okay. And there's this rider here where we are saying that in one plot, you can actually display one or more geoms, each added to the previously by just a plus sign. Okay. And that's why we are talking about ggplot being layered. You can keep on adding layers on top of the other. Okay. So to this end, what have we done? Number one, we have known how to load the packages, how to import our data, and how the data has been cleaned, and how it has been manipulated. So what remains now is for us to visualize that data set. Okay. So before we even go to we even go to our code to actually see some of those visualizations, uh, uh, you can see this just an example of a script that can be used in ggplot. So each and every layer or each and every component is added using that plus sign. Okay. And you can see here, my first layer is my data. That is the data set, okay, where we want to plot. Second line, we have the geometrics, okay? Which kind of a plot do I want? That line, we can have the aesthetics, okay? We can also have the theme. We'll look at the coordinates later. All these just form a part of a building block of a ggplot, okay? And if we just call something like ggplot data equals to HIV data, just by doing this, what it does, it just creates a canvas for you, a blank canvas. And this blank canvas is now for you to actually populate with whatever kind of visualization that you wish. Okay. So I'll stop there. Then will now move to our script now, to our script here. So as I was saying, to this end, I have this script whereby now I am assuming all of you have a clean data set. And what you're going to do here is now data visualization only under this. So, and if I run, this is what is called this is the 80% of what Ashna was talking about that has already been done. So what you're left with, we just need to do the other, we just need to do the other 20. So this was the cleaned data whereby uh, we can have the HIV category. So instead of just having 0 and 1s, we can now have 0 for negative and 1 for a person who was positive. Then we also created a gender column. So instead of 1, we have female, and instead of 2, we have male. Okay, this is just what is called recording of the categorical data. Then we also did the age grouping. So the age grouping is included in this what is called the age cut, just for age category. Okay, but you can name it any way that you want. Okay, then for this one there's a 25 to 49, 15 to 24, 0 to 14, 60 plus, and 80C. So this data set is already cleaned, but now we just would like to make more insights as to what it is all about. Okay. So as you have seen, first of all, you can see in my line 2 here, I've just loaded the tidyverse, and the tidyverse actually includes the ggplot. But you can also just load the ggplot too, and that will still be sufficient for you to do the visualization. Okay. So we're actually saying that since our data has been cleaned, we can now what we can do now is to create a canvas. Okay, just a canvas of where um, our we are going to do our plotting. Okay, and we are saying that remember our data here is called the HIV underscore data. This is the data set here. If you double click here, you can see it's the one which you are calling the HIV underscore data. Now, so if I come and say ggplot, because this is how ggplot, then it will ask me, it has options. The first one will be, we can call the data, and this is HIV data. There's suggestion for us there, HIV data. So if I run this, I've just loaded that data. And you can see on your uh, on my right hand side of the screen, just on the bottom right, you can see it. There's something which looks gray. So it means that ggplot has a default theme which it has already used. But for now, what I've just done, I've just created a canvas. Okay, it's just an empty plot area that now I would like now to add more layers to that canvas so that I can visualize my data. Okay, and for this one, I think it will just be good. We can just look at a very simple plot. Let us look at suppose I would like to do a scatter plot. Okay, and for this scatter plot, what I would like to do, I would like to first of all plot maybe the CD4 count versus the viral load. Okay, so it is important that you also know how those columns have been named, because that's exactly how we are going to call it when you'll be plotting. So you can see here the way the columns have been named is just a CD4, capital CD4, and also capital VL. So that's something that we need to know, that always has to be um, in order when you want to plot. So now, since I have already created that canvas, why can't I call that canvas here? Okay. Then inside that canvas, I would like now to add the aesthetics. Okay. And this aesthetics will include what I would like to go to the x-axis, what I would like, which column or which data I want to go to the y-axis. Okay. So for this matter, we can have a function which is called mapping, and you can see mapping what it does. Mapping this one gives you aesthetic mappings to be used when you're actually plotting. So if I use mapping, then I call IS. IS is just a short form for aesthetics. How do you construct the different mappings in that given data set? So if I press enter, now it has given me an option. What do I want for the x-axis? What do I want for my y-axis? So if I say, for example, I want x to be equal to the CD4 count, a comma. I also want y to be equal to the viral load. Okay. Now I have put the data, and I've also included my aesthetics. What else needs to be added? Because even if I run this one, it will still be blank. So what I need to do, because we have said that for each layer in the ggplot, we add it by using a plus sign. Is it? Then we have seen that if I want to get a point plot or a scatter plot, I need to call geom, and you can see that if I just write a geom underscore, it gives me so many options of the different types of visualization that I can actually find there. But in this case, I just want just a simple geom point, for example. So let me just look for point, like that one there. Then I can press enter. Just a simple geom point. Let us see what this will actually give us. So it's a uh, is a ggplot. I've actually called that data. There's mapping, is, there's x equals to CD4 count, and y equals to the viral load. Then plus the geom point. That's the one I want to plot. So if I press enter now, so you can see on my in this plot, what it has actually done, it has plotted the CD4 count on the on the x-axis and the viral load on that y-axis. Okay, so this is just a but a simple plot, but a lot can be done to this plot. Okay, for example, I have seen that in my data, it also includes it has been certified according to the gender. There's also certification according to the HIV status and also the age categories. So these are things that can be added. Even if I want these points are just defaults. These defaults I can decide which color I want, even besides black. Which color do I want to which am I comfortable with it being a circle? I can change it to be a square. I can change it um, to be a triangle and etc. Okay, but that's just this is just but a very simple plot. Okay, let us look at another simple plot that we can do, so that we can just get comfortable with actually doing the ggplot. So let us look at something like a histogram, a, a histogram, for example. Okay, so if I want to look at Instagram, I can just say ggplot. Okay, what do I want? I need to call my data, which is HIV, HIV data. Then I need to do the mapping, and for the histogram, since it's just it is just gives you the frequency of a particular parameter or variable. I just need to actually just call one, maybe is. Maybe I can say I want the x-axis to be sorry, I want the x-axis to be something like a CD4 count. Okay, then if I do plus, what do I want? I want to check. I want to do the geom histogram underscore histogram, something like that. Okay. So if I run this, you can see it has just given me uh, a histogram plot of different, or the numbers of the people with different values of the CD4. Okay. So that is just another plot that we can do. Another kind of plot we can do, maybe there's one which is normally called a violin plot. So these are just things that we can you can explore. But the most important thing is that any visualization that you pick, that you decide to use, it has to be, number one, easy to interpret, and it has to make sense. It's just not a matter of just plotting and seeing that you have something that has been visualized. It has to be easier to interpret, and it demystifies, or it makes the communicating of of the insights much easier. So again, for the violin plot, so in this case we can just have ggplot, just the same way, data, HIV. I can now map my, my data. So IS aesthetics, because that is what I want to do. Again, X, let's just use X equals to CD4 and Y equals to the VL. Oh, sorry, there's that error there. Then plus geom, because I would like to do a violin plot. These are just some of the plots that shows the distribution of data. So if I come and choose violin, so there are so many. All these are just different kind of geoms that can be used to visualize data. Yes, violin, geom violin is there. So I can pick that geom violin, and if I run it, you can see it actually just shows that uh, the distribution of that data for a CD4 count and versus the viral load. Okay, so this is just but one way that we can do the visualizations. But now uh, I think we can we can now look at visualizations whereby we can add more options. Okay, let us look at a way that we can now have some user-defined colors. We may want to change the colors. We may want to change the size. We may want to change the size of those of those points. We may want to change maybe we may want to stratify the plotting according to the gender. We may want to also include something like also to use the information about the HIV category and etc. Okay, so now uh, let's look at something. For example, we'll just start from a we can have a different plotting, which is maybe a box plot. A box plot, this one gives insights on if there are any outliers. It will tell you if there are any outliers, what are the quartiles, okay, what is the median of the mean, or what are the different measures of the central tendency that you may wish to see. So the same trend, we can have ggplot, okay. Our data, it is still HIV underscore, then the mapping equals to IS. Then what do we want to see in this particular box plot? Maybe on the x-axis, I want to have the HIV to see and check values for the y-axis. Um, we can have the CD4 count, is it? Then let's see. Then plus, then let's see. Let us call the geom box plot, geom underscore box, and see whether this makes sense. So if I run this, what it does is that it has plotted for me. It has plotted for me the HIV gender on the x-axis, whereby this will just give us the quartile distribution of the female. This is the upper part gives you the third quartile. The lower one gives you the 25th, or rather the 25th percentile, and the upper one the 75th. Okay, and the difference between the two, that is what is called the interquartile range. And this line here basically tells you a given specific measure of central tendency. It can be the median or the mean. Okay. So before we even continue with adding options on this particular plot, I would like us to go back. Would like us to go back uh, to our slides. So we've actually seen how some of these scatter, box, histogram can actually be. There's also density plots and etc. Okay. So now for us to be able to add user options or the kind of aesthetics that we want, we need to do we need to actually know which particular element do we need to change. It can be something like the shape if you want to display uh, the points of that geom point plot or that scatter plot. If you want it to be a star, you want to be a triangle, you can change it by using the shape. We'll just see shortly how this can be done. Then we may want to change the interior color of, be it a box plot, be it a bar plot. We may want to change or even the histogram. You may want to change, so we can use the option which is called fill. So fill equals to, now you can define the color, okay? Or you can define the color, or you can define the particular variable that will define the color of that fill. Then there's the color. A color now is used to define the exterior line of the, be it a bar chart, be it a box plot, and etc. Okay. Then we also have the size. How thick do you want that line to line of a geom line to be? How large do you want that point size of the geom point plot to be, and etc. Okay. You can also have something like alpha, which will just show you the transparency of that given point. This point which has been used in the geom point. Suppose I would like maybe to make it opaque. There are some values I can have here. I have option of using a given specific transparency that I want. Okay. We can also be able to choose the bin width of a histogram. Okay. If it's a bar plot, we can decide the width of those columns. Okay. If it's for the case where you have a line plot, you can decide which line type do you want, or what is the, you can have a dotted, you can have a solid dash, and etc. Okay. But now there's something which is called um, mapping uh, the colors that come into play when you're designing the different color variations of a plot. There are two ways this can be done. The first one, you can have what is called a static value, whereby you just say that I want a color to be equals to this. Okay. And if you say that color equals to this is what we call a static value, or an option which is called a setting. You just want to set the color to be equals to blue. And this will actually be applied across all the plotted observations. Okay. That is one way. The other way is what we call mapping. So you want to map a specific column of the data that will now define, or will now give you the color of the display of each observation. For example, if you use color equals to HIV gender, we know that gender, we only have male and female. So it means that the colors that will be defined for male and female will be different. Okay. So by doing this, this is what is a strategy which is called mapping. Okay. So when you're using static value, that is called a setting. When you're using a column of the data, that is what is called a mapping. Okay. And we'll see how these two can be applied, and why it's an important thing to know when you're actually visualizing. So this is just a summary of those different options of the aesthetics. You can have the color, you can have the feel, the size of the points, the shape, and the alpha. The alpha now is what gives you the transparency. It's a value between 0 and 1. So you can actually choose the values between there, depending on the nature of opaqueness or transparency that you want. Okay. So I think we'll go back uh, to our script again. So I actually don't know if at this point, do we have any questions so far? So please feel free to type your questions uh, in the chat, and uh, my colleagues and I will address any queries that you actually raise. Okay. Now this uh, is the box plot, and now uh, I would like now to use the mapping instead of the setting. We'll also look at the setting, how setting can be done. But since I have HIV gender here, why can't I also define or why can't I also map? Why can't I also map by? Oh yes, yes, thank you. Let me yes, yes, Ashan. I think that's it's actually good good practice to use mapping equals to is, then you continue. But it's true. You can just as I've illustrated, you can actually use it without the word mapping. So now let me do the mapping of the color. So I can say aesthetic, because this is also part of the aesthetics. Then I can do a color equals to HIV dot gender. Is it? Now this I'm using mapping because I'm not defining a specific color. I just want color to be dictated by by the column HIV gender. Okay. So what happens if I now run this? Just see what we have here currently. What we have here currently is just I can consider this just a bland because it's not even appealing. Okay. So if I now, because now I have added as part of my box plot aesthetics, I just want the color to be dictated by the HIV gender. So if I run this, you see now what has actually happened is that for the female, these are default colors. That is the red and the green. But as we move forward, you'll also see these are colors that you can also define and use the ones that you actually want. Okay, that is it. So besides now, inside the box plot, what actually happens? There's an option which is referred to as the notch. Okay, you will see what this notch is all about. The notch, uh, what it does, notch, we can say comma. This is just another option that we want to use. You can say notch equals to true, like that. Let's see what will happen to this plot. Notch, notch will just now show you where that measure of central tendency is there. Okay, and it's used to actually compare different box plots so that it can be easier to view where that measure is. Okay. In this case, so you can see that for the female, it's at about 500, while for the male, is, uh, is below that value. Okay. Now, remember also we said that when you're doing plots, you can have one or more multiple geoms. So, but what you need to do, you just need to add one on top of the other. Okay, layers. These are layered. So what will I do? I would like to add something like there's one which is called a geom jitter. We can this is actually part of the of the 40 over 40 geoms which are there in ggplot. So there's one which is called a geom jitter. Okay, and and geom jitter. Let us let us just plot it and see what comes of it. So you can see geom jitter, what it has actually done. What is actually done for the female, it is also plotting the actual points which were used to generate that particular box plot. Okay, and since this can actually be a good description of how the layering works in ggplot. You can see the geom box plot is now below the geom jitter. So the geom jitter is on top of of the the geom box plot. Okay. Um, Now, since for the geom plot, we use the mapping whereby the colors were defined or were dictated by the HIV gender. Suppose in this geom jitter, I would like now to dictate the color of these points. So I can say color, color, uh, color equals to, let me say something like, let's just say uh, green, for example, or blue, just for argument's sake. And for those who are using some of the versions of MATLAB, if you type the color, it actually highlights how that color will look like. So like this one, I've just typed the word blue inside the quotation marks, and it has just highlighted that text in the actual color that I've defined. So let's run that. If we run that, you can see now the colors have changed to blue. We can also go further now because now you can see the difference between this. What was used here was mapping for the coloring, mapping. Okay. What has been used in this geom jitter is what is called the setting. We're just setting the color, and this will be used. And you can see for this setting, it has applied all across the visualizations for both male and female. Now for this geom jitter, we can also have an option of changing the size of these points. So I can just size. Maybe I want something like 0.3, for example. 0.3, if you run it, you can see the points have become even smaller. Okay, maybe it's just something like 0.7. If you run with a size 0.7, they are much larger. Okay, and there's also that option of transparency. I would like to have my own defined uh, opaqueness of that jitter point, and I can say maybe something like 0.3. If I run this, what we have, you can see that the points now have become even uh, they are now faint than what was there before. Okay. Um, can we? So that is how we can use the setting and also the option of um, of size and uh, and alpha. Okay. Now there's also let us for the so this I was showing you about using the mapping. We can also do of another example of um, of the setting. So in this case, let me just do mapping just quickly. Yes, I would like to do uh, x equals to the CD form. Sorry, and y equals to the VL. Then I need now to add uh, my plotting, maybe the geom point. That is just geom point. What do I want? I can just set the color to be equal to, maybe just for argument's sake, maybe something like a forest. I don't know whether it's forest brick or something, or for a forest green, not brick. You see, that gives me the color. Then I also want the size. This is just about the setting. Size equals 0 point something like 6, and alpha I want it to be something like 0.1. It's just for argument's sake how the mapping can be done. So you can see it's actually very faint that even we can't see. So maybe we increase this to something like 9. Then if you select the line and run it, so it's much better. That's also another example of how setting can be done. Then suppose we want to have we want to do some statistics and add maybe uh, the bin width of a given histogram. How can that be done? So still we need to do. I hope you can see that there is a certain pattern or the uh, or how the building blocks have to be added. Okay, data has to be there. The aesthetics has to be there. You have the geometrics have to be there. You must have the options for the coordinates. Those ones we'll see later because what is being used now are just the defaults. And also the theme that you're seeing here is just a default theme. But all those building blocks have to be taken into account. If they're not defined by the user, what happens? R will take the defaults for that particular case. So you can have HIV data. So let's say we want to do for the histogram. And I know we are done it somewhere. Yes, this one here. Maybe I want to, let me just carry this one for the histogram instead of typing again. Mapping, yes. Not to be lazy, but let us just so that we can do it quickly. Then what are the options that I would like? So first of all, let us plot this, and we see how adding options will actually improve its visualization. So you can see it just looks not really visually appealing, but you can improve on this by adding some option inside the histogram. So we can have, and this will be, we can add something like the bin width. Suppose I want 20 of them, okay? But I also want that the color, this color, uh, this color will be blue. That will be the outline of those plots. We can also have another option. I want it to be the fill. What will be inside? What will be the color inside those bars? I can say something like black, perhaps. Oh, sorry. It has to be a black, perhaps. Then also I can have an issue of transparency. I can I can define how transparent I want this to be, maybe 0.2. So if we check this now, I can consider this as an improved version of the histogram. So you can see now what we have here is now an improved version of the histogram. And let us play around with the number of bins. Suppose I have something like 40. What will happen? And so this is just the mid with the size of that bin. So maybe I have something like 5, for example. 5, you can see there are so many. I think it will be you just do a balance of how you actually want them to be. So maybe something like 10. And blue does not look that good. Suppose I do this. Suppose I have it as black, then the fill to be something like maybe maybe like green, and the transparency to improve, maybe something like 5, for example. Then if you visualize that, yeah, I think this is much better. Okay, much better. So you can always play around with these options so that so that you can improve on on the on the visualizations. Okay. Uh, Another thing we can do, maybe if I pick this geom point that is from the scatter plot, let us look at some of the options that we can add. Maybe we can call this maybe adding a trend line. Just some other options. A trend line, for example. So in this case, so what I've done, I've actually just picked the one for the geom point. So if I plot this one, it just looks very unappealing at the moment, but I can just add more options here. Maybe I can add something like I want the size to be 1. Maybe to just increase the size of those points. I can also have something like alpha. I want to improve the transparency of the opaqueness. I can change the values. Then I can also have uh, so in this case, let me just let us see whether the visualization has improved. Yes, it has, but the values are not that good. Then maybe we have this as maybe something like 4. Then what do we have? Yeah, they're a bit improved. Then we can also add another geom. And in this case, what we want to add, we want to add a trend line. So remember what we actually talked about just a few minutes ago. And when you want to add a trend line, because this will be something like a regression, you need uh, to define a specific method that can be used for that function. So in this, maybe we can use a linear model, for example. Method equals to maybe lm, and we see. So this one is just, we're doing this on top of the geom point that we have here. So you can see in this case, it has just added a trend line of this plot of the viral load versus the CD4 count. So if your CD4 count is high, because the CD4 count basically measures how healthy your system is, and the higher the CD4 count, the better your health is. So we expect that for a person who has a higher CD4 count, that the viral load will also be very low. So this, for health researchers, it can be used even if you have, for example, the CD4 counts for a particular patient who has been whose this measurement has been done over a period. You can just plot it via and the CD4 count versus viral load, and you are able to determine whether this person has actually attained viral suppression or not. Okay, so you can add a trend line, and we will look later at how you can add a V line, whereby, or let's just do it and see. Maybe you have set a target, maybe a H line. Yes, a H line here. At what point do we want to add the H line? Maybe we can decide maybe at y equals to maybe 1000. Let's see whether this one will make sense. Horizontal line. Okay, we can always check on the documentation to know the options that goes into the H line. But that's just a way of of improving or deriving more insights from a particular plot. Okay. So do we have any questions up to that point? Any question? And again, this geom smooth. This is a line that you can also have some aesthetics for it. For example, maybe okay. Let's see. You can also define the size. You can define the size as the size equals to 0.5. What happens after that? To just the line has become even even thinner, and you can also define its color if you so wish. Maybe the color, I would like this color to be something like maybe red, for lack of a better option. Then you can change it to color. So I've just checked the geom, the options for the geom H line that we can do. So you can have that the y-intercept equals to, maybe we can just pick a value just for argument's sake. This value we can pick it maybe at something like maybe even maybe 1100. Let's see how that will be. So you can see if you want to add a line whereby you want to determine maybe at what point did this patient become virally suppressed. These are some of the other things that you can add to your visualization, or other layers that you can add to your visualization to actually improve uh, the information that is being derived from it. Okay. And for the HLN, again, it also has its own options. You can change the color, you can change the size, and etc. So let's just copy the options that we have here and see whether they'll also work for this. Sorry. So if you don't know, yes. So the same thing will happen. So you can also have the options of the size, the color, the aesthetics, uh, size, color, and etc. So even you can also use the line type to change the type of the lines and etc. Okay. So we have seen adding trend lines, uh, mapping the color using the mapping option and also the setting option, adding aesthetics, adding the geometrics using the data, and also uh, defining at least for a particular axis, what do I want the values here to be? Okay. Now, let us go back to our presentation. So we have seen how we set the static value here. So for here, we just define the color red, okay? And do the other options like the bin width, the color, the fill, the transparency, and etc. Okay. But when these are scaled to the column values, or what you're calling the mapping, that one is taken care of by the variables. So here you can see, oh, this is actually a good one. We can also try that. We may also want to actually color that geom point by HIV category, and also by the size, and the size to be the HIV category. That's a good one. We can try this one. So let me just copy that so that we can do it quickly. So for this one, what it means is that besides just having X equals to CD4 count and Y equals to the viral load, I may also want uh, to have the color being defined as by HIV category, and the size to be the HIV cut. Now, these two options here, it's not a must that they remain here. You can have them inside the aesthetics under the geom point. Okay, that's also another way of doing that plot. So if we run this, what happens is that it has plotted for us, but let us just go back shortly to that script. So the shape of that geom point will be a square, and the transparency will be 0.4. So what we wanted is that the color to be defined by the HIV category, which is just negative or positive, and the size to be defined uh, by the HIV category. So what can you notice here is that if I look at my legend here, the legend here only has positive and negative. Negative is supposed to be red in color. Or let me just do this so that we are able to see this. Let the transparency be something like 0.8. So if I run that, now it's visible. So now, a question here. You see, this one is positive, and the negative one is supposed to be this red color. Who can tell us why on plotting the viral load versus the CD4 count, we don't have any red any red square points in this chart? You can just type it in the chat. Why don't we have uh, these red square points inside in our chart here? We're just plotting the viral load versus the CD4 count. But our plot shows that even if we color by the HIV category, it's not we can't see any red square point here. So what do you think might be the cause for that? Because that's knowing that actually forms part of understanding how that visualization is, which is a very important thing to have information that you want to derive from such a given chart. So why do you think there is no red point? Why do there's no red point? Anyone? 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 And maybe just to give you a hint, you're thinking of this from a HIV point of view, that this person can be positive or he is negative. Okay. Uh, okay. So I can see a question there. Exactly. Sonia, you've gotten it right. Is that the negative ones do not have the viral load? Yes, because the negative person does not have any viral load, and that's why even if we want to color it by the HIV category, we will not see the negative one, because if it's a viral load, the negative ones will not be there. Okay, that's another good way that you can draw insights from that chart. Then maybe before before we go, I can also just mention something to do with what is called the facet grids, still on our on the data that we're using. So maybe what I can do, I can just come here and create a ggplot. Our data goes to the HIV data, the ones that we have. Then because I would like to get a histogram, let me just do mapping. Ludovic does not want this word mapping. X equals to age. Yes, because we have age in that data. Then what I want to do, I just want to do a quick geom plot, geom histogram. I want to do a geom histogram. Then for which I want to change the bin width to be something like 5. Okay. and I want the aesthetics to fill the aesthetic fill equals to age. What do I want the color to be dictated there? Which colors do I want, or how do I want the colors to be dictated there? Then we can have the color maybe equals something like maybe do we have gray, for example? Yes, you can have gray. So just defined how I want this to be. Then what else do I need to add? Now this is where the facet grid can come. So let's maybe I can plot first of all this one. We see how it looks like. Bin age equals to color equals to white. Data. Okay. Let's just add the other components. So the facet can do the facet grid. What I want to be the columns is the HIV gender. I can use this tilde, then I can have the HIV dot category. Then let's see what will this plot or okay. So by doing the facet grid, so like this one, I just wanted to do the histograms, the histogram for the edges, and remember for our data here, we could see that the ages were from 0 years because and 0 years can mean that somebody maybe it was a child, an infant of 1 month, for example, like in line 180. I remember when Ashna was doing the statistics, we had a maximum of I think 89 years or so. So even if I do the histogram for the ages and I do the bins, the bin width to be 5, and the ages and these histograms to be filled with age, okay, the counts of the people in that particular age, and the color. This just gives us the outline, the color outline of that bar. Now, because I would like to view, I want to see the histograms. That is for the according to the HIV gender and according to the HIV category. This is where now facet grid comes in. It ensures that on my column, I have the HIV gender, and you can see this is negative and positive. Then in my rows, what I have is actually sorry. This is we start with the rows, then we go to the columns. So the rows is the HIV gender. So, and you can see in this case we have the male and the female, but the columns are defined by the HIV category. So maybe this is what we call a facet grid, and this becomes very useful if you would like to do a bit of comparison in that data. Okay. So maybe you would like to compare different age groups who are negative or positive, and whether they were male or female. That can be achieved by using the facet grids. Okay. Something else we can also do at this point, since we are here, we may also wish to define. We may also wish to define the limits. For example, remember one of the building blocks was that we can also define the coordinates, okay, the coordinates of the axis. So it has a function which is called the code, if you just type code, it will just give you the code Cartesian, which allows you to choose the limits of the x-axis and the limits of the y-axis. So in this case, maybe for example, because I would not want to actually limit the values on the x-axis because these are edges from the data, I may wish to actually restrict the values of the count. Maybe I want this to go to something like the limit to be something like a vector from 0 up to 60. Uh, just something like that. Let us see what will happen to that facet grid. You can see that previously it was about 40, but now that has been increased up to 60. Okay. Then just for argument's sake, let us increase this to something like 100. What actually happens to that? You can see now it has increased it to 1 to 100. Okay. So definitely this other aesthetics you can actually change. Okay. You can change it. And if you want to add something like maybe the title of this graph, maybe you can use the function which is called the labs. The labs, this is just a way of if you want to modify the axis, the legend, or the plot labels. Okay. So suppose I want to change the title. I want to change the title of this plot to be maybe something like age distribution uh, by gender and status. Just something like that. Okay. What do we see after that? So you can see it has added that title for us there. Age distribution by gender and age. So and maybe what you notice is that for each and every building block that we are adding, we add it using the plus sign. The plus sign. Okay. That brings out the concept of layering when it comes to ggplot. You're just adding layers on top of one another. Now um besides uh, besides the facet grid, there's also something else which is called uh, the facet trap, for example, and we can also see how that behaves. So you can have a ggplot. Let us just use one of the. So we can use this is oh yeah, let us use the violin plot one. We just illustrate how the facet trap works. So CD4. I also want the fill. I want the fill of this to be by HIV.gender. Remember, these are just ways of defining the aesthetics using uh, the mapping strategy, where you want to scale the column variables. So geom violin, and I can do the facet trap. Oh, and there are so many as well. There are so many options when it comes to facet trap again, or the facet grids. So in this case, I just want to do the HIV gender, for example. What happens if I plot this? Yeah, so you can see for this one, it's just giving you those two variables. It's just comparing the male and the female, okay? Because you've just selected HIV, just the HIV gender. You want that comparison to be done according to the HIV gender. So if you want to do between two, so that you can have column and rows, then it will just be advisable that you use the facet grids. Okay. Now, once you actually done the plotting, you've added the labels and all this, you can just come here and export your plot. If you want to save it as a PDF, if you want to copy it and paste it maybe in a Word document, in a PPT, PPTX, you can also do it. You can also save it as a PDF, and that becomes a good visualization. Then the other thing maybe that we have left here, uh, maybe let's see, maybe I would also want to increase the limit and also add some labels, maybe something like that. This cannot be 100, so maybe increase to something like 10,000, and you see what happens. The title will be this is just maybe viral. Maybe we can just call it viral load versus CD4. VL versus CD4, like that. Let's run it. We see. Yeah, so the limits have increased from 0 up to 10,000. The other thing maybe we can look at is the theme. There are so many themes. This is just the default one. So and you can see if I just type the theme, you can have the the black and white, you can have the classic, you can have the dark, you can have the gray. All these are just themes that you can use. So let's just use one, maybe the light one, and we see how it will look like. So if I run this, you can see the background now has become even lighter. So maybe we can change the limits to something like a reasonable value, like 6,500. So this becomes yes. So you can see the background. And suppose we use okay, let us change the theme for the previous one. You can have the theme black and white, like that. So if you run this, you can see also for the other one, uh, the background becomes lighter. So you can always play around with the different types of themes according to how you actually want. So I think we are past the hour. So let me stop there for now, and you can you can do some practice. Then come next week before the final session, we can review some of the queries that you may have, and also review some of the plotting functions that we have done. And the only remaining thing will just be one extra plot that we'll do later, that will incorporate all the aspects of the building blocks of the ggplot, so that we can appreciate how powerful uh, this ggplot function is. So otherwise, I wish to stop there, and we will meet next time.